Hi, in this video we solve question number 10 of IIT Exam 2021 Mathematics paper. Here's the question. For n greater than 1, an integer, we have two statements for arbitrary n cross n matrix. The first statement is that the kth power of A is the identity matrix for some positive integer k, then all the eigenvalues of A are the kth root of unity. So what this statement is saying is the following. If the kth power of a matrix is the identity, then the kth power of all of its eigenvalues is equal to 1. Very well. Now here's the second statement. It says that if all the eigenvalues of A are the kth root of unity, then A power k is the identity. The second statement is the converse of the first statement. Right. Now let us understand each of these statements. For that, we recall the definition of eigenvalues. Lambda is an eigenvalue of a matrix A if there exists a vector x non-zero such that Ax is equal to lambda x. Now to understand statement A, let lambda be an eigenvalue of the matrix A. What does it mean? For some non-zero vector x, we have Ax equals lambda x. Now what you do is multiply on both sides by A, like this. This gives A square x is equal to lambda square x. Now go on like this. What you get is A power k times x is equal to lambda power k times x. Right. But what do we have in the statement? It's given that the kth power of A is equal to identity. So we replace A power k by the identity matrix here. We get In times x equals lambda power k times x. Very well. This implies that x is equal to lambda power k times x. Now take the term on the left hand side. What you get is 1 minus lambda power k times x is equal to 0. And this implies lambda power k is equal to 1 because x is a non-zero vector. This also means that lambda is the kth root of unity. So this means statement 1 is true. Very well. Now let's talk about statement 2. Now in statement 2, it is given that all the eigenvalues of A are kth root of unity. What does it mean? It means that if lambda is an eigenvalue of A, then its kth power is equal to 1. Now here is a useful intuition for matrices and eigenvalues. Any condition on a matrix gets easily transferred to a condition on eigenvalues, but not the other way around. For example, if you consider the following example, A is this matrix 1, 1, 0, 1. Now you can see that all its eigenvalues are equal to 1, which satisfy the condition that lambda square equals 1. So all the eigenvalues are second root of unity, but when you calculate A square, what you get is this matrix. The matrix 1, 0, 2, 1. This is not the identity matrix. So what does it tell you? It says that the statement 2 is false. So the correct answer is B. 1 is true, 2 is false.